Hi everyone. Today I'm super excited to host Zhihao and Robin, who are founders of Genia AI, generative AI platform for structural engineering. Can't wait to see the structural co-pilot they have built. So thanks a lot for being on the show.
Thank you so much for having us.
So maybe you can take us back to the origin stories of Genia, and even before that, like what's your background and how you led to this idea?
Yeah, so I'll start. Yeah, so my background is in structural engineering. So I was educated and I worked as a structural engineer. Right after graduation, I worked for Arab, so one of the largest design firms out there. Right? But surprisingly, the way like people used to design is using like 1,000 Excel sheets. So it's very repetitive and kind of tedious and all that. And after that, I have a timber residential house. But again, the process is still kind of tedious and repetitive. So it was like during COVID, I was thinking to myself, why there's not such a program or automation process that can kind of like just make the whole process automated. Right? So I saw that was like 2023, where the GPT, where the AI come out, where I met Zhihao in the startup. I bring up the idea, like we got really excited, especially, excited. That's where we started.
And I guess for myself, I did grow up in a construction family. My dad is a geotech, so he runs a consulting firm that does very much similar work. And for myself, growing up, observing him do the work, and then when I met Robin at the previous startup, it seems like the challenges he was describing was very much similar to what I observed from my dad's own workflow. Also for my own career, I specialize in launching new tech into new markets. I built most of my career in combining artificial intelligence with product management. So I specialize in launching essentially AI focused products into either a traditional market or into or building a new category from a product definition standpoint. Really see the opportunity here is that not only we can transform how people work in a relatively traditional industry, but also we see a new way for us to reimagine the AI native workflow, not only for structural engineers, but also for the industry dynamics overall. So that's what's really gotten myself excited about this opportunity. And that's leading to the founding of Genia back in 2020.
That's amazing. And Zihao, like from your like diving deeper into the structural engineering, were there any surprises which you thought, okay, this should be obvious. Why haven't we still using Excel? Or how was the your knowledge gathering process about this domain?
I mean, like quite frankly, the more that we work into this field or work on this field, the more respect that we show to structural engineers like Robin himself. The whole process is really uh there are a lot of moving parts in structural design, right? You have to consider the structural stability. You have to consider the building codes, which differ for every different county, at least in the U.S. Well, you also have to consider the materials that are available locally. So it's a very complex process. And the other surprising thing that really strike me early on was, even though civil engineering sounds like a science or engineering discipline, in fact, when it comes to layout design, it's actually more reliant on humans' experience, as opposed to having a golden rule or a set of golden rules, I guess, to determine the structural layout like in a scientific way. Oftentimes, we actually try this internally before we actually even try to explore AI. We literally sat down between the two of us and try to come up with a set of rules. And what we find out is even if we come up with the set of rules, let's say 10 rules, rule number 3 will probably be more important for this building. And for the other set of buildings, it will be the reverse order. So it's just surprisingly hard to come up with an exhaustive set of rules, and also B, to maintain a level of consistency across the set of rules. So that's essentially the main reason why we turn to AI. So because it definitely requires a level of creativity to come up with working design as opposed to just a rule-based approach.
Yeah, because depending on the typology, like that, as you were mentioning, the judgment becomes different because some weights are more, and that makes it difficult for deterministically way to make a one purpose platform. But
Exactly.
also, one of the thing I realize is there's so much knowledge based on each project where people learn from experience and hard way, and that's also not captured from one generation to another. Like, okay, I've worked on 50 projects, but like what were some hard decisions structurally you had to make, because that's not documented. Even for AI to learn, that knowledge base is in there. So Robin, what are, like, when you started thinking about the initial version of Genia, what were your hypotheses that it's high time for structural engineering design process to change, and how did you validate?
It's definitely just a personal pain point, right? So also like that usually like there's when I was working at Arab, there's usually like a group of us, just having the same pain point. We're communicating why, like this is it's just very obvious. Yeah. So when we started the company, we also like interviewed up to 100 different consultancies, right? So this is a common issue. I guess it's there, right? So it just there.
Frankly, we never really find ourselves convincing people why they need this. All of our discussions have always been focused on like whether we can actually generate a value design as opposed to, hey, you actually need an automation. So everybody realizes their workflow is repetitive. Like there's no like convincing for anyone, have been, really working on a design to sort of feel the, repetitive nature of the work. That's never really part of the conversation, frankly.
Yeah, that's one of the thing I realize about AEC in general is like there's so many pain points and people like, okay, if there's a tool there, we'll happy to use. One of the challenge then becomes is like the adoption, because a lot of people say, yeah, I feel the pain point, but when it's like, give us money and okay, like migrate, and then you suddenly see the difference. So I'm curious to know, from your perspective, we haven't seen like much more advancement in terms of structural engineering tools development. Like there are traditional software like eTabs, StatPro, and people have built plugins, but we haven't seen a lot of structural engineers even migrate. What's the core reasoning?
Well, so for us, I think let me first come back to the part of about adoption, because we also typically face challenges when it comes to AEC is traditionally not a very fast industry when it comes to adoption. People think it's that people are reluctant to adopt a new technology, but I think in reality, people are very keen about these kind of new technology. But then, what we always joke about is there's no what we call an MVP in the AEC space. MVP refers to minimal viable product. What we typically find is that if it's just only like 80% or 70% built of a product, then it's not really useful to anybody in this industry, right? So it's like in our world, the tolerance for level of accuracy is pretty high. You definitely need to have everything right in order to be useful. So I would rather say that people don't really need new technologies. It's just our industry really lacks a great product, because getting there is hard. Like I said before, there are a lot of moving parts. You have to do the design accurately. You have to consider all of the edge cases when it comes to like understanding the structural stability, the structural analysis part. You also have to be relevant to the local supplies of materials in order for your design to be relevant. So there are just a lot of moving parts. It's well beyond we typically see in the traditional internet space, where you can easily build a MVP and get verified in front of a customer. That's not going to be the case. You have to spend like a couple of years at least in the initial development and try to prove you're actually accurate and relevant to structural engineers in order to win their trust.
Do you have anything to add, Robin?
Like from the engineers we interviewed, even though there are people really excited, right? But there are people that anxious about the new technology, right? But it's common sense that the AI will eventually take over, right? So why not just hop on the train faster than later? That's my experience.
Yeah, like I feel a lot of times structural engineers get like bombarded with, okay, well, these are the new tools, check out. And how do you like being in the industry, okay, how do you make decisions? Should we adopt this tool? Should we build this tool internally at big firms, or should we try out a new startup? Like, what's the decision making framework a structural engineer goes through when testing a new tool or using it?
Sure. So the group of customers that we're going after initially are the mid-sized to smaller size engineering consulting firms for a couple of reasons. One is we started off focusing on low-rise, mid-rise timber structures, and it's typically these kind of firms that are working on these kind of buildings. We pick this kind of buildings to start with because there are a ton of them, mostly residential properties, and the structural analysis part is a lot easier to do as compared to, let's say, a 30 stories concrete building, right? So because if you think about the sweet spot for AI, it's pretty good at doing like things of a little bit of variation at a very fast speed. And it probably make a lot of sense to just start with the easiest kind of design as opposed to go straight to the very high tall that are really hard to analyze. So naturally, that's just a great starting point. For these kind of consulting firms, they don't really have the luxury to afford a software team. Let's say if you look at most of the bigger consulting firms like Arab included, AECOM, Thornton Sati, those firms are big enough to actually being able to afford a software team internally. But for the smaller and mid-sized consulting firms, they don't really have a luxury of affording a software team. So they don't really have a choice other than look externally. Otherwise, they'll be stuck in the Excel spreadsheets.
I see. What has been your proudest moment in the journey of Genia?
I would say, to me personally, at least, actually the first time when we actually generate a design for an engineering consulting firm for the first time. So I think it was a consulting firm in Vancouver where Robin used to be based at. So we got in touch with them through Robin's network, and then we were proof that we were able to generate something, even though in the hindsight there are a lot of defects in the in the design that we did. And since then we have been improving quite a lot in the accuracy that we do. So, but I guess the hardest part is always to get started, right? So
Yes,
the first design that we generated was the most.
So I guess like for me, we're, when we have a set of drawings that we generate, also like a set of report we have, at the time we show to the client, there's always, for some people, there's that aha moment, right? Oh, okay, this actually can provide value to us. So that's something that makes me proud, maybe.
I see. The reaction of when they see the final submission.
Yes.
And I also would like to highlight the point you made. In AEC industry, the MVP is not the right metric, because even if the product is 80% there, people oh, it's not there. Maybe once it's there, we'll try this tool again. So that's why maybe the 3 to 6 months MVP is not the right timeline. Maybe some products just need 2 years of development time to get into the hands. Okay, now it's solving my problem. I'm ready to pay. And that requires a different patience, funding, and other strategies. So what would be your then advice for people who are in the building in structural engineering space, that okay, have a different mindset of MVP and product development?
Also, I think my advice will be be a little bit more patient, because this industry is slightly different. You see all the hypes in AI from the Silicon Valley, which on its own is not really a bad thing, because it's attracting a lot of attention. But then sometimes you just have to identify the right kind of partners, be it investors or the right kind of customers or the go-to-market channels that are matching with what you're doing. Right? So this is an industry that's requiring a lot of more patience in order to be useful, right? So you have to respect that. So this is obviously not going to get the super hyped up valuation as we're seeing in the vibe coding in the Silicon
Yes.
Valley. So that's just the nature of what we do. So sometimes you just have to respect that, and don't get yourself too ahead of the time. I think that's actually going to be a bad thing. It's going to turn back into you. So just be a little bit more patient when it comes to product development.
And from 2023 to the initial days of Genia till 2025, what has been your toughest or most challenging phase?
Well, so I think I will say personally, getting, I think a couple of things. One of them was actually the initial phase when we were fundraising, because when we were funded in 2023, capital market was way different from what we were today. So fundraising was challenging at that time. So, but luckily we have gone through that process. We got so many rejections for various reasons, but I think if you pull it off, if you have the audacity and persistence to pull it off, then the remaining part will always be the rewarding part. The second part is where we, but when we generated the first set of drawings for structural engineers and we got so many challenges, it was really frustrating to see how we're going to prioritize all of these requests into our roadmap. So, and what we have been, so this is actually a real lesson that we learned sort of in the hard way. We have been so focused on building the core of the technology, like the Genia AI itself, the structural analysis engine. And what we haven't focused on, which we should have, was to build the communication layer with the structural engineers. Because earning trust is not just about doing things right, but it's also about proving that you're doing things right. That's essentially came as a hard lesson learned, because it was frustrating at a time when we were thinking, hey, we're doing these calculations right, but it was just because that we are not presenting the calculations in the right manner that engineers would like to see. So they'll probably stop reading on page 2 of the calculation sheet, of the 200 pages calculation sheet. So, that was a bit of a frustrating moment for us. But I think we went through that process, improving the readability, really rebuilt the calculation sheet from an angle of a of designing a product, and then that in the end turned out to be a rewarding effort. We start to gradually see the aha moment, like Robin mentioned earlier.
That's a great insight you mentioned, that the product might be solving the problem in the most complicated or technical challenge. But if the communication is not in the format which the engineer likes, then that also creates one challenge or friction layer.
Because people are pretty rigorous about this industry, right? Like Robin can maybe attest to this, like of how people review those calculation sheets. I feel like people will probably stop reading if they identify some small errors.
Okay. Yes.
Yeah, we were just saying, like, maybe Robin can attest to this, because this industry was a bit critical when it comes to assessing or reviewing a design, right? So if they spot an error, or if they spot something that they cannot understand, they'll stop reading all the way. So that's just the nature of structural engineers, because they're pretty busy, right? The way they make money is by selling their time and expertise, right? So if they spend like 20 minutes reviewing your calculation sheet, that 20 minutes is wasted on generating revenues. You better
Mhm.
real value in that process, and instead of just wasting people's time.
Got it. I think this would be a great time to show us some glimpse of Genia platform.
Sure, absolutely. So let me quickly switch to share my screen and play a demo video. We can go through this together, I guess. So this is a product demo video that we recorded when we're launching the product. So what we're building is what we call a generative design copilot for structural engineers. So it's a 3-step processes. As a first step, you upload the architectural drawings into our system, typically in DWG or Revit format. And then the second step is we parse the architecture that you upload, and then we explore as many generative options as we can with AI. Typically, we generate hundreds to thousands of different layout options. Not every single one of them will pass the structural analysis. So we'll have to assess their structural stability through a rigorous structural analysis step for each one of the generated options. And typically we'll be left with maybe 100 different options or a couple different options. And then for each one of our options, we'll further assess their structural stability, cost, sustainability, and constructability. So those are the 4 critical area that we understand, that we analyze. And then we typically try to recommend 3 different options to structural engineers to sort of provide them with more insights on the flexibility and stress testing of each one of the options. So our recommendation strategy typically begins with one option that's that's slightly cheaper, obviously meeting the bare minimum requirements of the building code, but maybe using less material and also be cheaper when it comes to the material costs. We also typically try to recommend one option that uses a lot more material, therefore are a lot more expensive, but inherently are more structurally stable. And we try to recommend one option that's somewhere in between. So by providing multiple options along the spectrum of the cost and performance trade-off, we give structural engineers insights into the flexibility of the design, so that they can make a informed decision when it comes to designing the best structure for the property. I believe structural engineers like Robin, when they were doing the design manually, they are actually going through this process by maybe considering like 2 to 3 different options, but they don't have the flexibility to explore as many different layout options as we can with the help of AI. So that providing value to structural engineers. So let's see how this plays out. So here we're showing you a real set of drawings that we have delivered for our clients. So this is a typical single family house. As you can see, these are the different floor plans. We log into our system, create a sample project in our system. Here we're also entering the zip code. So we use the zip code information for 2 purposes: that we check the local building codes for compliance. In this video, we're using a Canadian project in Vancouver, British Columbia. We also support the US building codes IBC, and we're integrated in the backend with ASCE 7, the association that's writing the codes, to directly obtain the environmental factors like seismic load, wind load, snow, all these factors that are impacting the design. So that's one use. The other is we're considering the local supply. So we want to make sure we're designing using materials that are locally available. So here we're showing you the different design options that we generate based on this sample design. So here's a bit of a summary page where we're showing the material usage, the constructability of each of the plan. And we also do a little bit of value engineering here as well to give structural engineers a rough sense of how much each of the option will cost. And along each of the options, we provide the structural drawings. So here's a rendering on the website. You can go ahead and hit the download button to download the DWG file if you want to access the raw file format. In addition to the structural drawing, we also provide a set of structural analysis results. So here's a bit of a pre-analysis for seismic and wind, and we also show detailed designs for each of the structural members. So here we're showing the different kinds of beams, joists, and if you look at the right hand side of the page, there's a force analysis report. If you want to see more details of how we generate these calculations, you can always go ahead and hit the download button, which I'll show you in a minute. That's where we can access the full blown 100 pages calculation sheet for the design. Sometimes structural engineers actually need to see that in order to properly assess whether the design is properly done. Right? But essentially, the value of our technology that we provide to structural engineers is to help them design a preliminary drawing 10 times faster, also allowing them to avoid 40% human errors in their design, which can typically cause months of back and forth with the government when it comes to issuing building permits. And also, we typically reduce around 10 to 20% materials design because we're able to explore many different layout options. So that's largely the value propositions. And I do want to show you one more thing, which is the calculation sheet. This is a design example from the IBC building code. So SEOC is a structural engineering consulting association of California. So in the building code, they put together a sample design. So we use this canonical example to show you what we're able to generate. So in our calculation sheet, we have a few things. We have the design basics, which describes the building code's topology that we follow. The second section is where we're describing the general statistics about the architecture and structure. The third part is where we are returning the architectural file that we receive. The fourth section is where we're doing pre-analysis of gravity, seismic, and wind. And the fifth section is where we're describing the design summary, summarizing the material selection for each of the structural elements that we did. And if you want to look into the detailed calculations, you can always go to section 6 and the following appendices. So let's jump right into each sections, right? So the first section is the design basis, right? So these are detailing the building codes that we follow, the different load combinations that we are using when coming up with this design. Section 1.3, we're going through a high-level methodology where you can understand a little bit more of how we model the structure and also how we perform the calculations. For example, we use the directional approach when it comes to wind analysis. We also use the ELF approach for seismic. You can always find that information here. The third section is where we're showing you the architectural drawings that we receive. This is the typical hotel in Irvine, actually, for this building. And the fourth section here, we are printing out the loading maps for each of the floor. We also show you the seismic load analysis. So here we're calculating the base shear at the grade level, and also we're distributing the base shear to each of the floor. So you'll be able to understand, how we arrive at this number by, the CS printed out with the seismic weight for each of the floor, and therefore the seismic load. And also we do the same for wind, right? So we, consider the total wind pressure and also being distributed to each of the floor. So with this consideration in mind, then we'll walk you through the detailed design for each of the floors. So here's a quick summary of our layouts. So you'll be able to understand how the structural layouts for each of the floor is. And if you zoom in to some of the tables to the right, then for example, if you look at the shear wall designs, so you'll be able to understand the material summary of each of the shear walls, the nailing patterns, the different kind of wall studs that we use, the controlling loading combos and the DCRs. So DCR stands for demand capacity ratio. And that's largely describing how well our selected material is supporting the force demands. And so you'll be able to understand holistically how well our proposed structural design is performing. And if you want to look into details of how we arrived at this number, you can click on the detailed design section. We actually picked one of the representative structure for each type. So for regular trusses, joists, beams, you'll be able to understand how we generate the designs in the back end. So this is a quick walkthrough of how these designs are made. This, by the way, is the same process as a human engineer would have done manually on Excel spreadsheets, which is automated. So we actually got asked quite often by structural engineers, hey, AI has the problem of hallucination, right? So how do you ensure accuracy? So our answer is that we use AI only for layouts, and that's where AI can sort of perform well on this creativity part. And for accuracy, we perform structural analysis in the same fashion as human engineer would have done. So that's our secret sauce for ensuring quality in our design. So yeah, I'll quickly pause here and stop sharing, I guess. And I guess I would invite anybody interested in finding out more about the accuracy. We actually keep a Substack channel. So if you go to blog.genia.design, you'll be able to see the CIOC example. We have a side-by-side comparison post of what we generate versus what the CIOC design example, the correct answer is. So you would typically be able to find the side-by-side comparison between our approaches versus what CIOC does. Yeah, absolutely. That's actually a great advice. We are always excited about introducing a chat interface to our clients. Because for our AI is a reasoning model, right? So we can actually expose the reasoning steps to explain why AI designed things this way. So that can give also a level of transparency to structural engineers. And also to your, we can enable interactions through a chatbot format. Engineers can give feedback on the assumptions that we take, on the methodology that we use. And also, we can point them to the right kind of place of information if I have certain questions. So that will increase a lot of more level of interactivity and essentially make people feel that they own the control, they own the design, as opposed to becoming a design reviewer and start picking errors and problems. That's actually what we're currently working on, and in about a month or so, we're going to release another version of the interface incorporating exactly what stay tuned for that. Yeah, so I think for now, our website only has the design summary, which is a very high level summary. So in the version that we're going to release, we're going to make what we show in the PDF. A lot of the information that we show in the PDF, we're going to make a copy of that into our web interaction as well. And to your point, we can direct people to the right place of like where the information is, and then hopefully that will improve readability.
Yeah, so basically, so right now, like definitely gonna release the editor for users, and as well, like right now we're supporting like timber, but we'll be fully supporting steel structures and concrete structures. So like right now we do support timber for vertical and horizontal forces, so that's a complete set, right? Yeah, so right now we do also support the steel for vertical, but we'll be supporting horizontal for both steel and concrete. So that's a step. If we can get that target within next year, then we'll be incorporating more components of building, right? So say mechanical system, plumbing, things like that. We'll also.
And then very recently, we just signed a client, which I cannot name. So we're going to support them for concrete design as 5 to 6 stories apartments, maybe up to like 150 to 200 units. And they're based in Nordic. So we're now supporting Eurocos during this engagement. So, being a US company with a UK investor, PyLab investment, by the way, we've always been very excited about entering the European market. So this is our, first attempt of international expansion beyond North America. It's always about how we can it's a balance between keeping expanding with offering the right kind of customer experience, because we definitely don't want to lose the level of services or quality when we're supporting more clients. We've always been constantly thinking about how we can turn some of the onboarding or make the onboarding experiences a lot better for our clients. So that's been some of the motivations for building the editor interface, also improving the user experience on our web-based SaaS tool. So that's going to be a constant effort.
Sorry, I didn't quite get your question. Okay, there's still opportunity. Yeah, that's a great question actually. I think what we do is like we do like the layout and the whole structural design, like the whole design package. But within like different very specific areas, there are still opportunities, right? For example, I was thinking the other day, like for concrete mixing, right? So with different combinations of like aggregates and cement, there's like always different strength of kind of cost versus strength options. So that's like very specific issue that I'm thinking of sometimes.
And I do have a few more ideas actually. We never touched on anything like physical. We're seeing a lot of remodeling that requires physical examination of the existing structure. So we're not doing anything closer to that, but that's a big opportunity for anything that's involving like a revamp of the structure. We also are focusing on